Well, hi there. So in this video, we're going to be taking a little bit more of a deep dive into an interesting thing that banks do, which is creating money. So normally we don't think about banks as like being the things that actually create the money. We actually usually say that the central bank creates money, which we're going to learn about in the next section of this unit. But banks haven't actually just regular old banks like World, U.S. Bank, Bank of America, that kind of thing. They play a role in this money creation process. And it's kind of spooky, but we'll kind of see how it goes. So there's a little bit of math, but I'm going to do the math for you. So don't get scared about that aspect. And it's more just proof of concept than anything else. So the first thing to know is that banks do create money, which you know that because I just told you. But as part of the loan process is actually how they do it. So they create new money and they expand the money supply just by lending out more dollars. So first, kind of imagine a banking system in which banks have to hold 10% of their money in reserve, and they do, and they don't hold anything else in reserve, and they loan out all of the other 90%. And that every dollar that gets lent out gets redeposited back into the system. So, in other words, nobody is holding any money in their wallets, nobody's holding any other money except the money that gets loaned out, and then it immediately gets redeposited. Now, if it helps you to think about it as just like one bank doing all this, that's fine. Or you can think about a multitude of different banks. It doesn't really matter as long as basically all of the money that gets loaned out gets redeposited and then gets loaned out again. So there's this kind of effect happening. So we'll start out with a situation in T period 1, which is kind of what I'm going to list here. And I'm going to switch it over actually to a spreadsheet to show you how this will work. In T period 1, someone walks in and deposits $1,000 in cash, right? So that's what this table is telling us. So then there's this total deposits of $1,000 because that's the only deposit in the whole system. The bank keeps $100 in reserve, and so that means their total reserve is 100 bucks, and they give out a loan for 900, which is the 90% that they can lend out, and so the total amount is 900. Now, this 900 that gets lent out, the new loan, gets turned around and redeposited right here, 900, and that's from the T period 1 loan, right? And I'm just kind of noting that that's where this money is coming from, is over here as the new loan. Now that means that kind of you have a new deposit. That means that the total deposits are 900 plus 1,000, so it's 1,900. Now the new reserves, right, are 10% of the 900, so there's new reserves of 90 for a total reserve of 190 because we add the 90 to the 100 we already had in reserve. And that means now that of this 900, we had to keep 90 in reserve. 810 could be loaned out because we had to keep 90 of the 900 in reserve. So again, the difference is what we could loan out. So now the total amount of loans is 1710. So we can see that like every single turn here, the new deposit's going to be a little smaller, and the next loan is going to be a little smaller, and the next reserve is going to be a little smaller. So the new loan of 810 goes over here and becomes the new deposit, right? Someone else deposits it, and that's from T period 2. And so we know that like the total deposits is 2710, right? If we add 1900 and 810, and the amount that they have to keep in reserve is 10% of this $810. So they have to keep 81. So this is 271. And we know that of the loan, right, 810 minus 81, I'm just going to say, let's do this. I'm going to basically extend the formulas. And we can see here to 729, right? 729. And those two together is 2439. And I'm just kind of rounding these as well. And we know that the next round, 729, is going to, that's the next deposit, right? Because we lent out 729. That means that gets deposited. And so that's going to be added to the 2710, right? So now we're up to 729 plus 27. You can see why I decided to use this with this in here, 3439. And we know that they have to keep $72.90 of this amount, 10% of this in reserve, right? So 72.90. And that means there's, what is that, $343.90. And then 600, the leftover amount that we can loan out is $656.10. So that means the total amount that we've loaned out now is 3,095.10. We'll do this one more time to kind of start to see the pattern start to emerge here. T's period 5, 656, and that's from over here, right? And that's 10 cents. And then that means the total amount of deposits is now 4,095.10, 65.61. What does that say? 409.51. And then that means we can loan out $590.49. And so the total amount of loans is 3,685.59. Again, the actual math here doesn't matter as much as kind of starting to notice the pattern. So as we do this new deposit, the new deposit gets smaller and smaller every time, and it's going to approach zero. And in fact, I'm going to let you to wonder how many T periods before the new deposit goes to zero, because you can see eventually these new loans are getting smaller and smaller every time. Because right, they're reserving 10% every single time. So how many T periods until this thing goes to zero? All right, I want you to say it right now. No cheating. All right, now put a little number, and let's see. So let's see if your T period was 20. No, we're still doing this cycle here where there's a new loan getting created at $135. But you can see what's starting to happen is it's getting smaller and smaller every time. And now maybe another question would be, what would be the largest amount, do you think? So eventually we know that like the new deposit's going to go to zero. What's the total amount of deposits going to go to? It won't go to infinity, because every single time you can see it's growing by smaller amounts. And eventually when there's a new deposit of zero, it's not going to grow at all. So where does the total deposit stop? And that's actually where we're really kind of noting this function is happening here, and where maybe these other things would go to. So kind of ponder what these numbers might be for a moment. And you can actually kind of start to see this one gets to 790, 878, 880 or so. Where do you think these numbers are going to end up, right? And we know that eventually new deposit, new reserve, and new loan are all going to end up at zero. So let's go down to T period 40 and see what happens. Ooh, we're getting very close here. So see, now we're down to $16 is the new deposit. The new reserve of that is obviously $1.60, then $14 and some change for a new loan. Now this one is getting awfully close to something here, right? Notice we're kind of getting closer and closer. Hopefully you're starting to pick up on what that closer and closer value is here. Oh, we're still getting a new loan of $2. Somebody borrowed $2, and then total deposits 900 and whoops, hang on, 9,900 something. Okay, let's go a little farther. T period 80. Now we're really starting to see the pattern, right? So hopefully at this point you can probably guess where these numbers are going to end up at. If we know that this one and the middle one and this one are going to end up at zero, what does that one look like it's going to end up at, right? What does this one look like it's going to end up, and this one? Okay, let's go a little farther down. Oh no, oh no. I'm losing control of my own spreadsheet here. There we go. I have to go over. There we go. Oh, we're getting close, but we're not quite there. We're still getting new loans. What is this? A new loan of 3 cents. That's not very much, but it's still a loan. So let's see. Ah, there we go. So what did we get to? We got to T period 117, and it eventually ticked over. But you can actually see that there's probably, I know for a fact that there's fractional cents going on in here. So in fact, let's kind of extend it down and see really far down, 150. Ah, yes. So here we can see what it eventually goes to. All right, is 10,000, 1,000, and 9,000. So we know that eventually that new deposit goes to zero because there's no leftover 10%, but this one eventually goes to $10,000. This one goes to zero. This one eventually goes to $1,000. This one goes to zero, and this one goes to $9,000. Now, in fact, we didn't have to have a spreadsheet to do that. We could have actually used something that's called the money multiplier to very quickly ascertain actually what would happen. So the total deposits, and this is actually real money. So just if you were wondering, like, money creation process here, these are real people who have money in their bank accounts, right? If you borrowed money from someone and then you put it into your bank account, it's still money in your bank account. It's still there. It's in your checking account. You can go get it out as money. Yeah, sure, you owe money to somebody else, But that doesn't even actually matter as much. Imagine in this circumstance as if we loaned out $900 to somebody, somebody who then spent the 900, all of it, and then that person who they spent it on, that person deposited all of it. Well, that $900 is real money in their checking account. So just by this initial deposit of $1,000 plus the lending activity that went along with it, we now actually have $10,000 in total deposits. So of the 10,000, only 1,000 was from the original deposit, and $9,000 of new money got created through this process. Now, there's a few observations we can make. There's 9,000 new dollars from this process, and every single new dollar actually comes from loans. So if we wanted to know how much bigger the money supply is, we could actually just count how many dollars got loaned out. And that's kind of nice that we've got this column here that totals up to 9,000. That's how many new dollars got created as a result of this process. The total amount of money at the end of the process is 10,000, but of course we know that 1,000 of that was from the original deposit. We can also say that bank reserves from the original deposit of $1,000 actually went up by $1,000. It's kind of a weird coincidence here, but it is true that basically those bank reserves through the lending activity would raise up to that amount. Now we can make these calculations by simply creating, as I said, the simple money multiplier, which is M, and it's 1 divided by the reserve ratio. Now in this case, the reserve ratio was 10%, so 1 over 0.1 is equal to 10. And so what we could do is we could start with any of these initial numbers, multiply them by 10, right, except for the new columns, because those columns are basically are accounting. And we multiply by 10, and we can find that that holds true. So 10 times 1,000 gives us 10,000. 10 times 100 gives us 1,000. 10 times 900 gives us 9,000. So it's a very quick and easy way for us to see, like, what's the maximum change potentially in the money supply. And we would say that the change in total deposits does not equal the change in the money supply. Now, this is sometimes where students get mixed up because this is some complex stuff. But remember, the original deposit was already in the money supply. So if we wanted to know what the change in total deposits is, it's different from the change in the money supply. Remember, the change in the money supply is how many new dollars got created. And we can actually just see that that's the amount of the loans. So just kind of be aware. I'm going to walk you through two kind of examples of how this might happen with bank deposits and withdrawals. If a person deposits $1,000 in cash, we know that the M0 goes down by 1,000 because there's 1,000 less currency. But the amount in total deposits initially, right, this is key here, initially is it goes up 1,000. So the initial effect on M1 is nothing. We know that kind of they cancel each other out. But in the long term, this is where it gets kind of wacky. The long-term effect on M1 is the money multiplier times 1,000 minus the original deposit, right? Because we wouldn't say that the original deposit, that was already in the money supply. So we'd say that it's, in this case, it's whatever that multiplier is times 1,000 minus the $1,000 that was already deposited. So it might pay to just write like already in the money supply. That's why we subtract it out, right? And so that way we know the total is 4,000. But in this one, we would say the long-term effect on the total deposits. And by the way, I don't know that I actually even wrote like what the money multiplier, there would have to be 5 here. So we'll just say 5 for our purposes. In the total of change on deposits, though, would be all 5,000 because this 1,000 wasn't in the deposits beforehand. So that's kind of the tricky part. If a person withdraws 1,000 and the reserve requirement is 0.2, so actually this part here should be up here as well. R equals 0.2. That's how we get 5. The initial effect is obviously there's $1,000 in new cash. There's $1,000 less in deposits, and M1 didn't change initially. But in the long term, right, that money multiplier 5 times negative 1,000, but minus the 1,000. And again, we're subtracting this 1,000 because it's already in the money supply, right? It's already in the money supply. And where was it? Well, it was part of the M1 money supply. It wasn't in M0, but it was still in M1 because it was in a checking account. And so the total change in the M1 would be negative 4,000 as the result of someone taking cash out of the bank. So when people hold cash, right, we can kind of suppose it to say that that actually makes the money supply smaller. By holding cash, you're preventing banks from doing all of this lending activity. And so that's a little bit of a trick to this, right? If people deposit more cash into the banks, then the banks can loan out more money, and so it increases that lending activity. Now, there is kind of one last little caveat to the money multiplier. There's two factors that make the simple money multiplier maybe too simple for reality. The first is that banks don't loan out all their reserves, right? So one thing that would hold back this process from occurring is if the banks decided they weren't going to loan all that money out. If they didn't, then that whole process that we just saw below wouldn't happen as quite as large. The other factor would be that households don't always redeposit all the money that's loaned out. Again, if you decide to hold cash, then you're not going to continue this lending process. And we'd say that actually quite a bit of our cash is held in physical currency. To account for both of these factors, actually, a more sophisticated money multiplier is to have the monetary base divided by the M1. This is not on the test, not on the exam, but something like this is on the exam. And the distinction here would be actually that you're going to be asked a question probably that asks, why would this money multiplier effect not be as large as you thought, right? So this might be like, why the expansion, or we could say more broadly, why the expansion or the change in the money supply isn't as big as predicted. And it's because people hold cash and banks don't loan out all the money. All right, hopefully this helped you. I know this can be kind of confusing. We're going to do some practice problems with it. I'll see you next time.